Okay, hello everyone. So, in last lecture we have started the steam generator, right? That means a boiler. So, what is meant by steam generator? Generator, right? And which can be utilized further wherever it will be required. Can be used to generate the power, or can be used for sterilization purpose, can be used for cooking purpose, or something else also. Okay. So, the main function of the boiler is to supply the steam at a required constant pressure, which will be actually designed. The boiler is basically designed as per the requirement. And for the boiler, it is ensured that whatever the steam you are supplying, its quality is dry. Okay, what is meant by dry? We have already discussed in the previous lecture, right? Dry, or it should be superheated. That means there should not be any moisture content in it, right? Then further that we have discussed about the classification of the boiler, right? So let's revise it again in a short time. According to the axis of the shaft, sorry, axis of the shell, it is classified as horizontal boiler, vertical boiler, and inclined boiler. Okay, so depending on how its orientation is, I will show you today the different models. Then next one is according to the application, that where your boiler is going to used. Okay, so let's say if it is used for power plant, then it has to be stationary because anywhere, right? And the next one is some industries need steam to be supplied at a different locations. Okay, but they don't need a very heavy amount of the steam, right? So in that case they can use the what you can say, mobile boilers. Then for the next one is according to the location on the of the furnace. That means where the furnace is mounted, whether it is inside the whole shell or outside the shell. Okay, that means if it is inside the shell, then it is an internally fired boiler, and if it is externally, okay, external, that means whatever the furnace is, if it is something little bit side from the whole shell of the boiler, then it is known as a externally fired boiler. Then next one is according to the type of fuel, what kind of fuel you are using over there. If solid fuel like coal, wood, so that is a solid fuel boiler. If liquid fuel is there, then liquid fuel boiler. If gases are you are using the gases, then it is a gaseous fuel boiler. Then next one is according to the method of circulation of water. Okay, see, if depending on the density, if the water is circulating inside the boiler, then it is known as a natural circulation boiler. Okay, then next one is forced circulation boiler. That means in this case the water is not actually circulated due to the density difference. Instead it needs a external mean for the circulation, so there will be a use of a pump so that you can circulate the water manually. Okay, and you will get the required results. Then next one is according to the flow of water and flue gases. That means where basically the fire is existing and the water is existing in the particular boiler. Let's say if the fire is there inside the tube, then it is known as the fire tube boiler, and if the fire water is inside the tube, then it is a water tube boiler. Okay, I have shown you the differences also in a one particular figure. Yes, you can see here on the left it is water is there inside, and surrounding it is the, or you can say, flue gases. So that's why it is known as water tube boiler, because water is inside the tube. And fire tube boiler is the on the right side, where you can see fire is there inside the tube and surrounding it is the water. So that's why it is said as a fire tube boiler. Okay. Now let's see a few differences between the fire tube boiler and the water tube boiler. So flow of water, where the flow of water, that is the first, or the flow of gases, hot gases, that is the first parameter. Fire tube boiler, definitely fire is there inside, or hot gases is there inside the tube, and surrounding it will be the water. In the water tube boiler, water is there inside the tube and hot gases are outside the tube. Then mode of fire, actually it depends on boiler to boiler, but normally for fire tube boiler, it is the internally fired boiler. They are mostly internally fired boiler, while water tube boilers are externally fired boiler. Okay. Then next one is the operating pressure. See here, fire tube boiler. Here, fire is there inside the tube and it is surrounded with the water. So you can see water is very, what you can say, that fire is very less contact with the, there will be very less contact with that water, right? So in that case, there will be a very, you can say, low amount of the heat transferred toward that water. So that's why the pressure obtained over here, over there, because the volume is bigger one. Okay, so in that case, what will be what will happen, the pressure obtained will be low comparatively to the water tube boiler. So you can see here, maximum pressure you can obtain is about only 16 bar, while in a water tube boiler, as the water is there inside the tube, so you can see here volume is less. Okay, so water is having less volume and it is gaining more amount of the heat from the hot gases. So in that case, what will happen, as volume is, what I can say, it is inversely proportional to the pressure. So what will happen, as the volume is reduced, you can see, you can get basically more amount of the pressure over there. Okay, so maximum pressure which you can obtain in the water tube boiler is 75 bar. Okay, then next one is a rate of steam production. So definitely, if you can see, if it is a fire tube boiler, so you can say volume is bigger one, so steam production rate is less because it needs more and more amount of the heat, okay, at a time which it cannot receive. Okay, so that's why it is having a low rate of the steam production. While in the water tube boiler, as the water is inside the tube, that means you can get easily, or with a very less amount of the fuel also, less amount of the hot gas also, you can get the more amount of the steam in a shorter period of time. Okay, then next one is the application. It is suitable for chemical industries and not for power station, definitely, because you are not getting very high pressure, high pressure over there. So that's why it is suitable for the chemical processing plants or the food industry plants, for the sterilization purpose or for sometimes cooking purpose also. Okay, then next one is the, yes, in a water tube boiler, ideally suitable for power station, because you are getting very huge amount of pressure over there, right? So that's why it is suitable for a, just a minute, that is why it is suitable for power plants. Then next one, you can see risk of bursting. So as the pressure is not very high in the fire tube boiler, so definitely risk as compared to the fire tube boiler, water tube boiler is less. Okay, of course 16 bar is not very again easy task, but still comparatively it is less. Okay, then next one, you can see here that for the water tube boiler, for the water tube boiler, um, it is not safe because it is having a very huge amount of the pressure. Okay, then treatment of the water in the fire tube boiler, it is not essential because you are not mostly using it for the power plants, and as you are not using it for power plants, so there will not be more contamination, or you can say less, there will not be any contact with the turbines. Okay, while here in the water tube boiler, it is water treatment is essential. The main reason behind is that it is passing through the tubes. Okay, and the tube size is very small. Okay, so what will happen if you are sending the contaminated water over there, or impure water over there? So what will happen, the chances is that there may the passage may get blocked, and if the passage will get blocked, or what you can say, um, sediments will be there inside that tube, then in that case the cleaning will be very difficult, because it is a fired sorry, water tube boiler. So you that tube cleaning is very very difficult, and along with that the heat transfer rate will also decreases, because it will be covered with the unwanted material over there, right? Or you can say क्षार, जो आपको पता है हिंदी में हम लोग बोलते हैं क्षार, उसको बोलते हैं, right? So those sediments will be there over there. Okay, so that's why it is not suitable, or you need to do the water treatment before sending it to the boiler. The next one is a shell diameter. Fire tube boiler, it is a large for the given capacity, because as it is a water tube boiler, so definitely we need more space to store that water over there. And in the in the water tube boiler, the water is actually passing through the small tubes. Okay, so as per the capacity, the tube size is actually, or the shell size is small. Okay, then next one is the characteristic of the boiler. So steam boiler generates a high amount of the steam with low fuel utilization. So this is very big, very important. What you can say thing is there, that whichever the boiler is there, whichever boiler you have designed, okay, it should produce the steam with a low fuel utilization. Okay, definitely you can create the fuel. Okay, so you can prepare the steam. Okay, you can convert the water into the steam with any amount of the fuel, but jitna low hoga, that will be much more beneficial, because you are so going to um, uh, reduce the cost ultimately, right? So this is what is important. The next one is, it must be less weight as well as needs small space. Definitely agar size you can reduce, so definitely what will happen, the space required to mount that boiler will also reduces, as well as the costing will also reduces. Okay, then next one is, it or you can do it or its installation cost will also reduces, right? Then next one is, it be starting. Okay, see, the boiler is actually quite difficult, because operating is quite difficult, because
Ma'am,
difficult.
voice is
uh,
breaking.
that boiler is difficult, because what happen, the fire may not catch quickly. Okay, as well as, even if you start if even if the fire will start, still the circulation of that flue gases to the whole boiler, okay, it will also take time. Okay, so that's why it should that boiler should be designed in such a way that it should start with a minimal time. Okay, then next one is as well as as well as need less concentrations. Okay, that means what? Boiler cost is already high actually. Okay, but when you are designing it, it should be designed in such a way that its cost should be less, as well as needs less concentration. Matlab what means what? That means maintenance should be less. Okay, as I said just in a previous slide, that in the fire tube boiler, you need to maintain or you need to supply the treated water directly. Okay, why? Because otherwise it will be very difficult to maintain, right? So that is the one of the thing that how you can reduce the maintenance. Then next one is, this boiler handles any kind of fluctuating load. If the load is increasing, that means if the requirement of the steam is more, okay, so that boiler should be capable to supply more, as well as if the requirement is less, then it should be capable to supply less also. Okay, and supplying less means what? You should reduce the supply of the fire also in that case. Okay, so likewise it should be suitable for the fluctuating load. Okay, because every time the requirement of the steam will not be same. For example, let's say as the steam is used in a turbine, so in that case, every time the power required will not be same. Okay, as I explained in the previous unit, that in the morning time it is quite higher. Okay, in the commercial in your domestic area. Okay, while in the daytime it is less, again in the night time or the evening time, as the all the people are at their houses. Okay, so in that case, again at that time the requirement is more. Or if you're talking about the commercial areas, so in that case, mostly more amount of the energy is required in the daytime, while in the night time requirement is less, right? So accordingly, basically, the boiler should be what you can say suitable for the fluctuating load. Okay. Then next one is a boiler mounting and accessories. Okay. So I would like to show you first the boilers, and then we will discuss the different mountings. Okay, and the accessories. So just a minute. Okay, hopefully you all can see. Yes, can you see the image?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So the one which you are seeing here is a Babcock's boiler. Okay, Babcock and Wilcox boiler. So this is a horizontal axis boiler. So you can see here, it is mounted horizontally. Your tubes are mounted horizontally. Okay, shale also you can see on the top side. Okay, so this is the shale. This is the shale which is horizontal. So this is the horizontal type of boiler. Okay, so these are the main tubes. These are the main tubes, and you can see this boiler is basically water tube boiler. Okay, from this side there is a furnace. Okay, so this is the grate on which basically your fuel will be placed. Burning fuel will be placed. Your all the flue gases are they will pass through this. Okay, and after that the remaining flue gases will be thrown outside through this chimney. So this is the chimney you can see. Okay, and this is the tubes which contains the water, and the water will takes the heat from that flue gases, and then whatever the steam generated or the hot water is, that will be collected in this shell. Okay, this is the superheater. We'll talk about it just in a few minutes. Okay, when we will move to the boiler accessories. For now, just you can see the model which is actually showing you the Babcock Wilcox boiler. Okay, then next one, this is the Cochrane boiler. So yes, you can see here the second one is the Cochrane boiler. This is the fire tube boiler. Okay, this is the fire tube boiler. These are the tubes from where basically fire will be sent. Okay, inside the boiler. Okay, you can see this is the vertical type of the boiler again. Whatever the flue gases are, they will be collected on this chamber, in this chamber. Okay, just a minute. Okay, so you can see here it will be collected in this chamber and then sent through this chimney. ऊपर से आप chimney भी देख सकते हो. Okay, sent to the outside the system through the chimney. Okay, then next one, this is the Cornish boiler, again a horizontal axis boiler, but this is the fire tube boiler. Okay, this is the again fire tube boiler. The first one we have seen, that was the water tube boiler. This is the water tube boiler because water is inside the tube. Second one is the Cochrane boiler, which is also sorry, it is this is the fire tube boiler again. Okay, Then next one is this Cornish boiler, which is again a fire tube boiler. Okay. Then next one, this is the Lancashire boiler. Looks similar to this Cornish, slight difference is there. And this is also the what you can say fire tube boiler. Okay. The last one is Loeffler boiler. So here you can see this is the Loeffler boiler. Okay. This is also a fire tube boiler. Sorry, water tube boiler, not so fire tube. This is a water tube boiler because water is there inside the tubes. Okay, and fire is outside it. So this is the water tube boiler. Okay, now let's talk about the mounting. Okay, mounting means what basically? Everything. Okay, every individual equipment which is mounted on the boiler so as to operate it safely. Okay, so that the operation of the boiler will be safe. That is what is known as the boiler mounting. So there are a number of different mounting of the boiler is. So first one you can see on this top side, that is the stop wall. Okay, so here you can see this is the stop wall. Now stop wall, what it is going to do basically, whatever the steam which has been produced inside the boiler, okay, that water or sorry that steam will be provided to the place wherever required, and to operate or to control the how much amount you are supposed to supply, that is actually controlled by this stop wall, steam stop wall. Okay, then next one is this safety valve. Okay, you have seen the pressure cooker at your home, right? So whatever the what you can say this that whistle, okay, so that is one kind of the safety valve. Is what it is doing, it is releasing the extra pressure. Okay, releasing the extra pressure. Let's say if in the boiler if this happens that the requirement of the steam is reduced, has been reduced, but the steam inside the this shale is continuously accumulating. Okay, so what will happen, the pressure will increases, and if it goes beyond the design limit, so in that case this safety valve will get open and it releases the some amount of the steam into the atmosphere, so that your boiler will be safe. Otherwise what will happen, this whole thing get burst. Okay, so to avoid that the safety valve is used. Okay, then next one is the water level indicator. Just let me see whether it is visible on this side or not. Yeah, so here you can see on the other boiler. So this is the water level indicator. You can see it looks same like this one. Okay, actually also it looks same like this. Okay, so what the water level indicator do, basically whatever the water is there inside your boiler, okay, continuously the steam is going to utilize. Okay, so in that case you need to supply more amount of the water again inside the boiler. Okay, so to check whether the level of the water inside the shale, okay, it is what you can say it is good in amount or not. Okay, so to check the level of the water inside this channel, okay, sorry, or inside this shale, this water level indicator is used. Okay, then next one is the pressure gauge. So here you can see the pressure gauge. This is the pressure gauge. What it is going to do, it is going to check, okay, the whoever the operator is. Here also you can see, here also you can see the pressure gauge is there. So whoever the operator is, he can check from that pressure gauge that how much pressure is there for the of that steam which is going to coming out from that shale. Okay, so that is what the pressure gauge is. Then next one is the safety. We have talked about the safety valve, right? uh, Blow off cork. Okay, so blow off cork. Yes, so you can see here in the Cochrane boiler, this is the blow off cork. Now what this blow off cork will be doing? Okay, see what happens, boiler contains water. Okay, and every time or it is not possible that whatever the water you are sending into the boiler, that will be the purest form. So definitely it will contain some amount of the mud. Okay, so that mud basically will be collected at the base of the boiler. Okay, it will be collected at the base of the boiler, but timely you need to throw it out of the boiler. Otherwise, what will happen? Its um, performance will reduces, right? The boiler performance will reduce. So to throw that mud or the contaminant, okay, or the whatever the sediment is out of the boiler, this boiler cock will be opened timely. Okay, maybe probably uh, twice a day. Okay, this will be open. And when it is going to open, what is going to happen? Basically, inside the boiler the pressure is very high. Okay, so when you open the valve, with that very high pressure, water will come out. Okay, and as the pressure is very high and the water is going to come out of that, it will also carry that sediment with it. And likewise, you can reduce that contaminant from the boiler. Okay, so this is what is the blow off cock is. Then next one is the fusible plug. So fusible plug, um, I don't know whether you can see it here or not, but let me tell you the location of the fusible plug. Okay, so you can see here. This is the Babcock's Wilcox boiler. Okay, so here is the grate, basically where you are going to place the fuel. Okay, and exactly at the top, you can see on the inner side there is a shell. Okay, so at this exact position, the fusible plug is placed. Okay, now what this fusible plug is? Let's say what happened. Let's say the heat inside the boiler increases to very high limit. Okay, um, beyond maybe the design. So in that case, what will happen? The fusible plug will contain uh, a metal. Okay, which will get melt uh, at a certain temperature. Okay, which is the actually you can say limit temperature for the boiler. Okay, highest limit temperature of the boiler, beyond which if the boiler will go, boiler temperature will go. In that case, what will happen? The boiler will get damaged. The different parts of that boiler, they may get damaged. Okay, so the fusible plug is made of the metal. Okay, which will get melt as soon as the pressure temperature of the boiler reaches to the certain limit, to the highest limit. Okay, so what will happen? That fusible plug, which is located exactly at this location above the grate, above this grate. Okay, so what will happen? Fusible plug which contains a metal, it will get melt up. And what will happen when it will get melt up? As the fusible plug is there inside this uh, boiler shell. Okay, inside this water shell, someone has turned on the mic. Please please mute it. Okay, so the fusible plug is connected to this shell. Okay, at from this bottom side, right? So what will happen when that fusible plug, when that metal will get melt down, that will come at this down on this grate, and along with that, the water which is there inside this shell, it will also come out, and it will actually what you can say. Shut off that fire. Okay, and likewise, basically what will happen, you can stop the boiler when it goes beyond the extreme temperature. Okay, so this is what is basically the fusible plug is. Any doubt in this? Yes, hopefully no. Then next one is the manhole. So you can see here, this is the manhole. Okay, similarly, this is the manhole for the Cochrane boiler. Okay, and for the Cornish boiler, here is the manhole. Okay, or the door. Similarly, on this Lancashire boiler also, you can see this is the manhole. Okay, here in the okay, so now what is this manhole is? Whenever the maintenance is required, at that time these manholes are there. Okay, through which the person can enter into the boiler and can clean up wherever, or clean up, or maybe whatever the required maintenance has to be done, that he will do it. Okay, so that is what the manhole is. Then next one is a uptake header and downtake header. So it is only in the actually these are not the mounting, it is inside the boiler. Okay, so you can see here in the Babcock Wilcox boiler. Okay, this main tubes, they are a little bit inclined. Okay, they are placed little bit inclined. This is the uptake header and this is the downtake header. Okay, now why this arrangement is there? Okay, so the reason behind is that this Babcock Wilcox boiler is a natural circulated boiler. Okay, that means due to the density difference, the water is going to flow. Okay, so here you can see what is going to happen. This is from here the water will enter. Okay, whatever the water is going to enter, it will be cold water comparative to that one. It will be cold water. Okay, so what will happen? It will take the heat from here. Okay, sorry, extremely sorry. So this is the intake. Okay, so this is the intake. Okay, here is the intake. Okay, so from this side it is the cold water is there. Okay, it will take the heat from the surrounding flue gases, and that water will then get heated up, and that means its density will increases. Okay, sorry, decreases. Its density will decreases, and as its density decreases, it will move toward this uptake header. Okay, and from here it will be then circulated back to the top shell. So this is how basically the natural circulation is there, and just for that you can see the main boiler, it is placed little bit inclined so that the natural circulation can take place. Okay, so these all are the what you can say boiler mountings are. Okay, then next one is the boiler accessories. Please, before going to the accessories, please let me know whether there is any doubt regarding this boiler mounting. Yes, anyone? Any doubt? Hello?
No, ma'am, no doubt.
Okay. So let's move to then the boiler accessories. Okay, now what is meant by boiler accessories? We have seen boiler mounting. What boiler mounting is doing? It is helping to operate the boiler with safety or the requirement, what is to satisfy the requirement. Okay, or which actually helps to operate the boiler, simple language में, which helps to operate the boiler. Okay, with a efficiency, good, not efficiency, properly. Okay, properly operate होने के लिए जो help करने वाला, that is known as the boiler mounting. Okay, now next one is the boiler accessories. Now boiler accessories means what? The additionally you can use the different devices in the boiler so that you can increase the efficiency of the boiler. So that is what is meant by the boiler accessories. Now there are different 6 different boiler accessories. First one is economizer, then preheater, then superheater, feed pump, steam separator, and the steam trap. Okay, so let's talk about this one by looking at this Loeffler boiler. Okay, just a minute. Okay, so now you can see here, this is the Loeffler boiler. Okay, and we are going to see the boiler accessories in it. Okay, so on the top side, you can see this is the air preheater. Okay, but before going to that, let's understand basically how is the flow of the fuel here. okay, flue gases. So this is the entry of the fuel. From here basically oils are splashed, okay, and it will catch the fire which is already burning here inside the furnace, okay, and this is the point from where the air is going to enter, and it combines with the oil, and the what you can say a burning action will take place, and it gives you the flue gases which is at very high temperature, okay. The highest temperature will be at this point, okay. Then after that whatever the flue gases are, it will move upward, okay, from this direction likewise, and then from this top you can see the, and on the top you can see the hole is there, okay. From that hole it will go into the chimney and then into the atmosphere, okay. So you can see here at this position, as the boiler is going to or as the fuel is going to start burning at this position, it is having the very high temperature, okay. And after that the temperature, less temperature is somewhere here, then lesser temperature is quite somewhere here, okay, then less one is here, and then the less one is the here, and then outside the what you can say boiler, okay. So you can see likewise the flue gases, it is losing the heat in this manner, okay. Here it will reduces some amount of heat, then here it will reduces some amount of the heat to the this evaporating drum or to the main boiler, okay, main tubes. Then it which whatever the remaining flue gases, remaining heat in that flue gases is, that will be then taken by the superheater, then by the economizer, and then by the air preheater. Now you can see here, if only the main tube is there, okay, you don't have any of these accessories, so what will happen, you need to get the same amount of the pressure, you will need more and more quantity or more size of the main tubes will be, okay. There will be requirement of longer size of the tube, okay, or the size of the boiler will also increases, okay, when you are not using any of the boiler accessories, okay. So what these boiler accessories are doing, they are reducing the size of the boiler and also increasing the efficiency with the less amount of the fuel, okay. If only the main tube is there, that means what will happen, you will require more amount of the fuel to convert it into the required quantity of the steam or required pressure of the steam, okay. What these boiler accessories are helping, they are helping to reduce, to get the same pressure, same temperature, same quantity of the steam at the outlet with the less amount of the fuel, okay. So here you can see now, this is the air preheater at the top. So what it is doing, it is taking the air from the atmosphere, and from here you can see that air here, there is a the flue gases are going to flow on the top side, that means it will contain a few amount of the heat, that heat will be taken by the outside air, that means air will be preheated and then sent into the furnace from this bottom side. As you are sending the preheated air inside the furnace, that means you can ensure that the fire can be catch easily, and the what you can say, if you are sending let's say colder air, so in that case what will happen, the some amount of heat will be required to heat up that air, okay, already, okay, and then the remaining heat will be then given to that boiler, right. So to avoid the heating or additional heating of that air, the air will be sent which will be already preheated, so that is what is the air preheater, okay. And as you are using it at the near about the near to the exit of the flue gases, so what will happen, whatever the remaining heat is there, that will be taken by that air preheater, okay. The another advantage of this is that you are trying to utilize more and more amount of the heat from that flue gases, okay. Then after that, so this is what is basically the entry of the preheater. Now next one you can see, this is the economizer, okay. Before economizer, let me show you that this is the pump, this is the feed pump, boiler feed pump, okay. That means what it is going to do, it is taking the fresh water, that fresh water will be pumped by using this feed pump, and it will be sent into the economizer. Now again economizer is placed on the top side of the boiler, just below the air preheater. That means after remaining heat from the flue gases, that will be sent toward the economizer. Okay, so economizer, what is it is doing? It is preheating the water. Whatever the water you are taking, fresh water you are taking from the feed pump, that water will be preheated, and then it will be sent out. Okay, and then it will be sent to the main boiler, or to here, in this case it will be sent to the evaporating drum. Okay, then after the evaporating drum, you can see here, this is the outlet of the other side. Okay, so from here the water will be pumped to this channel, you can see. So here it is, the this is the radiant superheater. So as I told you that here the heat will be very high, and whatever the heat, okay, which is due to the radiation, that way it will be transferred into the water which is already heated, preheated in this economizer. That water, okay, it will take the radiant heat, that means very high heat. Okay, and then the water will be getting it is now in the steam form, because it is a superheater. Okay, so whatever the steam is, that will be taken from this evaporating drum. Okay, that steam will be passing through this superheater, radiant superheater. Okay, and then after that it will be passed into this convection superheater. So here the heat will be transferred due to the radiation. Here whatever the heat is there, which is in the form of the convection, it will be transferred into this superheater. Okay, and in the superheater, what will happen? The very high temperature will be developed. Okay, very high temperature and a very high pressure will be developed. Okay, then after that you can see, here is the outlet from the superheater. Okay, and this is the basically outlet of the steam. So wherever the steam is required, from here that steam will be taken. For this type of the boiler, that is this Loeffler boiler, 1/3 of the steam will be taken to the place wherever it is required, and 2/3 of the steam will be sent back to the evaporator, so that whatever the water is there inside the drum, that will be converted into the steam. So this is what is basically for the Loeffler boiler, but not every time it is same. Okay, in other type of the boiler, let's say like in your Babcock Willox boiler, here you can see this is the main tube. Okay, water is going to take in inside from this tube. Okay, so heat will be transferred into the tube. So you can see, this is the, we have seen the heat exchanger. If you remember, in the heat exchanger we have talked about the counter flow. So you can see, from here is the hot flue gases are entering. Okay, and from here the cold water is entering. So it is a counter flow, opposite direction. Hot flow is going to flow from this side to the other side. Okay, and cold water is going to flow from this side to the other side. So it is a counter flow. That means the efficiency will be good in this case, right? So whatever the water is there, it will be completely converted into steam. Okay, into in this main boiler tube. Okay, and then it will be sent back to this container. Okay, to this boiler shell. Then that water, okay, it some whatever the steam which is going to trap inside this shell on the top side, that steam will be sent into this superheater. You can see here. Okay, so this is the superheater. From here, in this superheater, you can see the diameter of the pipe. This diameter is bigger as compared to this one. So as the volume is less, so what will happen? And still it is going to take the heat. So in that case, what will happen? The pressure obtained will be more, because volume is inversely proportional to the pressure, right? So in the superheater, volume you have reduced, as well as still it is going to supply the, or it is going to take the heat from the flue gases. So you, at the exit, you will get more and more amount of the pressure, and that will be again collected back into the tank, and wherever, sorry, that will be then sent to the place wherever required through this steam stop valve. Okay, यहाँ से entry है, you can see from here is the entry, then it is going to circulate like this, and from here it will be sent to the outside place wherever required. Okay, so this is what is basically superheater. In the Babcock Willox, economizer is not shown here, but it is there again. Okay, uh, so this is what is about the boiler mounting. Feed pump we have seen, economizer we have seen, air preheater seen, superheater we have seen. Okay, then next one is the steam separator. Steam separator, we don't have actually the what you can say a model for that. But what steam separator is basically doing, it is same like this tank. Okay, almost, but smaller one, same like this tank. Okay, water which is going to collect at the this basically steam separator is used, separating the steam from the water. Okay, so this is what is the steam separator. Okay, so now let me show you the Cornish boiler. Okay, so here you can see this is the Cornish boiler. Let me open it. So here you can see this is the outlet for the flue gases. From here the flue gases will be taken out through this chimney. Okay, these are the controllers for the flue gases. So like this basically you can open and close the entry of the exit of the flue gases. Okay, through this what you can say plates. Okay, similarly it is there on the other side also. Okay, so this is what is the boiler shell. Now here you can see this is the externally fired boiler. This is the externally fired boiler. So the furnace is there outside the shell. Okay, then this is the door for the fire. From here the flue gases, okay, flue gases will be taken inside. Then the water will take the heat from that flue gases, and the remaining one will be just a minute. Oh, I'm so sorry. Yes, this is the externally fired boiler, but here is the basically furnace. Okay, then okay, so from here basically the flue gases will come, okay, and it will enter into this channel. You can see this is the channel. Okay, so outside जो शेल का है वहां से भी आपका जो है हीट water को जाने वाला है. Okay, same from the bottom side also. Okay, and same from the inner side also. Okay, and the remaining will be, it is going to come on from the other side and will be sent into the atmosphere through the chimney. Okay, so this is what is the your Cornish boiler. Okay, now difference between the Cornish boiler and the Lancashire boiler is that this is having the two tubes. Okay, two holes are there, two doors are there. Okay, double pass, you can say double pass is there for the flue gases. So this is the Lancashire boiler. Okay, so this is what is all about the boilers. So if you have any query, you can ask. Yes, anything if you want to ask. Hello.
No, ma'am.
Okay. Okay. So here is the end of your unit number 2.
खत्म हो गया मैम यूनिट 2.
हाँ खत्म हो गया. Just a minute. So here is the end of your unit number 2, and from next lecture we will start the unit number 3. Okay?
Yes, ma'am.
Ma'am.
I have marked your attendance already. So those who have query, they can wait and ask me the queries. And if no query is there, you can leave the meeting.
मैम एमसीक्यू के लिए क्वेश्चन प्रैक्टिस भेजो ना मैम।
हाँ हाँ भेज रही हूँ मैं आज शाम तक मैं आपको भेज देती हूँ।
ओके मैम।
एक प्रैक्टिस टेस्ट भी
Okay, ma'am.
भेज
Thank
दूंगी
you.
आपको।
ओके मैम।
ठीक है ओके
ओके मैम,
थैंक यू वेरी मच।
थैंक यू मैम।
केयर मैम। मैम ठंडी बहुत है मैम।
थैंक यू
Thank
मैम।
you, ma'am.
बहुत ज्यादा ठंडी है थोड़ी केयर करो अपनी।
हाँ मैम।
थैंक यू मैम।
ओके
Thank you,
थैंक यू
ma'am.
वेरी मच थैंक यू वेरी मच।
मैम।
Take care, ma'am. Thank you.
या all can leave